So some time ago I got this one, which I made a video that I repaired it, and there's a YouTube video that I did. Its main problem was the rubber idlers that were very damaged, and I repaired them by grinding the outer surface of them. Now I got another one, which I don't know which version it is, transistor or valve version, but I will now do a hands-on with it. What I did before I tried, I set the voltage selector to 240 volts. A friend of me suggested that I should do that. I have heard this before, but I never did it. But now that this is suggested, maybe valve machines are more prone to failure when the voltage is higher than normal. So here in Greece, the normal voltage is 230 now. Back some years ago it was 220. So the 230 is a little bit higher, so it suggested that we put the 240. Actually, let me see how much voltage do I have. It's 226 my voltage. So it's more than 220, so it's not bad to put it on 240. That's already done. There is a small selector back here where you just pull it out. Just like that. Come on, get out. Come on. It's not that easy. Okay, that's it, as you see. And there is a notch here, and if you see the 240 on the notch, can this be seen? Yeah, there, exactly. If you see the 240 on the notch, this is the setting for 240. 240, I think, was the nominal voltage for United Kingdom. That's why many machines have 240 also, but I don't know which other countries. So now I will start the hands-on on this and see how it works. So cable is already on plugged in, and now let's see what we have here. The machine looks to be in good cosmetic condition, so I'm not afraid that it will be bad cosmetically, because I can see it, but I'm afraid there are problems with the functioning of the machine. I will check it right now in front of the camera and see if it works and how. So power on. A lot of noise. This is not working correctly. This machine normally has an idler, then when you put it on fast forward, it lifts up so that it bypasses the clutch that is on this plate, and that's how it goes quickly, fast forward. Now it's not doing that. That means that this idler is not lifting up, and it stays before the clutch mechanism, and now the clutch is working. That's why when I stop it, it stops. Okay. Rewind works. Let's see. The play seems to work, but it's a little bit noisy. That means that the idlers are not very good, but it's not extremely noisy, so it might be fixable. I have to check it. Now let's plug in the speakers to see mic. I think this is mic. Let's see the other side. These are the speakers here. So one speaker is plugged in. The other speaker is plugged in. And let's see if we have sound. This speaker is noisy. This speaker is not noisy. So generally the machine has problems because it does not produce any sound. It makes a lot of noise. Let's see if this works quickly. It works. So the machine works mechanically, but electrically we have no sound. So very low volume sound, but generally noise. So next thing to do is that I plug it on my speaker, external amplifier, and see if through the amplifier I get any sound. So plugging this through my amplifier, I also hear a lot of noise, like that, and starting this, it doesn't produce any sound. The video meters seems to move a little bit. I don't know in which way they move. So looks like there is a problem with the power amplifier of this, the final stage of the amplification. But I don't know exactly, I have to check this. That's all. Bye bye. So this is the case. I have here two SONY TC-200. These are valve machines, as you can see. And this one works correctly, but this one doesn't. I opened them both here so that I could compare something, but unfortunately I cannot compare them because they are not equal to each other, and I will explain later. So let me show you what is the problem with this one. Let me plug it in. There we are. Let's just... So motor is turning, everything is working. I have there one speaker, and this is the plug, and I will put it in. Okay. And listen when I turn up the volume. You see the sound? If I turn down the volume, which is here, the sound stops. If I put it on, I get this sound. If I put the speaker on the other speaker, which is here, I get the same sound from the output. And if I turn down the volume, it stops. Okay, I will shut it off now and tell you what I have found. Generally, I try to do stuff with my limited knowledge because I'm not an electronics technician. So I just do this for fun. Because of that, don't trust me in what I'm saying, but I will try to do my best. What I have done first here is, can you see this capacitor? This is the original capacitor. These are two capacitors in the same can, and there is another capacitor under there. Let me see if I have my flashlight here. There it is. So there is another capacitor down there. So these are three capacitors of 100 microfarads, okay, on high voltage. Another thing to say is when you see machines that work with valves, normally these machines have high voltages on the boards here and there. So be careful when you work on machines with valves, because the high voltages are not expected. Normally for preamplifiers and small audio amplifiers, you're not afraid of high voltages here, but if you have valves, then this is the case. Here we have voltages above 100 volts. So if you have such machines, don't touch things now and there without knowing what you do, because this is dangerous. So let me show you. If you can see the three capacitors there, and the three capacitors here, I have replaced them with modern capacitors. They are there. And just to eliminate this factor, to be sure that the problem is not on the power supply. These capacitors are for the smoothing of the power supply. This machine does not have a full bridge rectifier. It has this diode, so it has one diode, and the voltage is rectified with one diode and the capacitors. So let's go and see what we have. This is the machine. My serial number is below that there, concerning this machine. So this is the schematic. That thing has three stages of amplification. One stage here, one stage here, and one stage here. Okay, the first stage is a transistor. And the next two stages are valves. If we look at it here, the first stage is around here. The second stage is here for one channel and here for the other channel, and the final stage is here for one channel and here for the other. So these valves here are like that. These are two combined and these are two combined. These are the transformers for the output of these two valves. Okay, valves need to have a transformer for the output because they output high voltages, and the speakers need low voltages, and we use the transformers to lower the voltage. Okay, this is how it works. Well, from what I've seen, if I turn down the volume, which is this potentiometer here, then the sound stops. So my limited knowledge makes me think that the problem is before this volume. So I guess the problem is somewhere here and not somewhere here. I will check it later and tell you what happened. I'm not sure about that. I checked all the capacitors if I have a sorted capacitor, but I didn't check them if they are off specs because I have to desolder them, and I didn't want to do this right now. Now, I try to compare these two, but there is another problem. The one that's not working is below this serial number here, but the one that is working is between these serial numbers. And this is a germanium transistor, but this is a silicon transistor. So if you see the voltages here, for example, let me show you. Here, for example, we have 12.8 volts, but there we have 1.1 volts, and the rest applies to the other voltages there. So I can't check the voltages of this transistor, of this machine compared to this machine, because they have different arrangement, and the different arrangement is these two germanium transistors, which on the newer version are two silicon transistors, which are right there. You see, this is the silicon transistor, this is the germanium transistor. Next of all, this sound that we heard looks like a leaky transistor. I'm not sure if that is, but it looks like a leaky transistor. So what I thought is that here we have the auxiliary input, which goes through this capacitor, through a resistor, like that, goes like that. Like that, goes like that, goes on the other side, goes there, and goes to the input of the volume. So what I could do, if I take out this part by taking out something, maybe the collector of the transistor, or maybe this resistor here, so that I stop the power supply of this part. I'm afraid that if I take out this resistor, that will raise the voltages on this part, so I don't think I'm gonna do that. I'm gonna take out the collector of this transistor to stop it from working. So just one of these three, I don't know now which one. I think is, anyway, it doesn't matter, I will do it. And see if I still have sound, if I still have noise on the output. If I still do, then the problem is not here, but it's here. If I don't have noise, then I know that the problem is somewhere here. Furthermore, if I don't have noise here, I can feed in signal from here, which will go like that, and will go to this potentiometer. This is the volume potentiometer. It's written here anyway. And if I get the sound from the output, I mean audio, that means that all this part is working perfectly right, and this is the problem. So that's what I'm going to try to do now. I will desolder the collector of this transistor and see if we still have strange sound on the output. If this is the case and this is the problem, I don't know if I can find this transistor somewhere. I will look for it. I will even try to replace it with the silicon transistor, because according to these voltages, the problem with the silicon transistor is that they are biased higher than the germanium. But if this is biased on 12.9 volts, that, as it says, a silicon transistor may well be biased in place of this germanium without any problem. The newer version has some differences on the resistors around the transistor. That's why here we have 1.7 instead of 12.9 volts that we have here. So I will first put a silicon transistor on this place, if this is a problem, of course. and then I will see if I have output, and then if the output is not good, I will have to mess with these resistors and these resistors that control the bias and the output, and see if I can make the output better. So this is my case now. I will take out the transistor, I will desolder one pin here, the collector pin, from one of the two, and see if the audio works correctly. So, this is what I did. As you can see here, come on, focus. Whatever. Here I desoldered, you can see it here, and you can see it also here. I desoldered the collector of the two transistors, and power on. And no noise on one channel. Let me put it on the other also. Here also. Volumes are on maximum. Furthermore, if I did put some line in here, and if I start, no, I also have to press the record here, and I have sound. I have sound. The sound is heavily distorted, but there is some sound and there is no noise. So that makes me think strongly that these transistors are the problem. I will try something else. I will put the collector back in and take out the base and see if I have different results. Maybe an electronics technician would laugh now with what I do, but this is my way because I don't have the knowledge to do it better. Anyway, so let's see now if I do this, what we get. Guess what? The problem for the distortion was not this, but it was the speaker, because I used another speakers. Now I have 4 speakers, as you can see. My living room is a mess now. I have, from the 2 Sonys, I have 4 speakers, and I tried another speaker and listen. And the other channel, no. Okay, I will stop now the music. So, from what I can imagine, my valves are all working correctly, and the problem is here. I did check the capacitors, the electrolytic capacitors around here, and I found no short. So that means that it's not a problem of the capacitors, maybe, but I guess the problem comes from these transistors. Now, I will try to see if I use another transistor, but I don't know if what kind of replacement I'm gonna find. I will search and see, but I don't know when I will be able to show any results here. So there is an update of what I did so far. I replaced the original germanium transistors with a BC. I will show it to you. Come on, focus. I think now you can see. It's a BC547. Both of them. So I replaced the original germanium transistors with the BC547. Let me show you. Under there it's the base. This is the collector here, and this is the emitter there, and the same applies for these two. If I touch, first of all, there is no noise, okay? That indicates that the problem was the transistor. If I either touch the base, you can see, you can listen the sound, the emitter and the collector. And the same applies to the other channel. Base. Okay. So, it looks like it's working, but let me show you. I put a tape on it. One channel gets normal output, but the other is very low. Not to mention, don't bother by the mechanical noise that this does. It's just the take-up reel idler that's making this noise. You see? If I lift it, it stops. And if I attach a microphone here, if you look at the schematic, you may see that the microphone goes through this transistor, like the head. So, if I attach a microphone and I press look, 1, 1, 2, 1, 2. You can see that one channel has a lot of gain and seems to work okay, but the other channel this is full. The other channel is working, but has lower gain than the first one. I really don't know why. I don't know why. But it looks like I'm on a good route, meaning that I know that the old transistors are bad, and that I may replace the transistors with silicon ones, and it might work. So I have to try some silicon transistors now, and see if I have some good results with it.